Hi, and welcome back to Serial Killers. In the words of the rapper Timbaland, it's been a long time. I shouldn't have left you without a dope beat to step to. Yeah, it's been a few months since our last podcast, and that's because we've been really busy here at Utrema. We did a slight pivot in what we focus on this year because it's been so... the weather's just been awful, so arable crops have really suffered, and not many people have been looking for any inputs for those arable crops. So we pivoted towards focusing on people who've got waterlogged new build houses, and we've been selling the product, our liquid gypsum product, which improves the drainage of clay. We also launched a wetting agent called Clay Drainer for those people. So that's what we've been busy doing this year. So sort of seeing out the storm until the autumn, so we can get back focusing on arable crops. Josie is busy finishing off exams for her students over at Malton College, and she's busy researching the next podcast that she'll be focusing on. Today's podcast is going to be about blockages and what causes blockages, how to solve them. I know that this is a massive issue for farmers, and whenever I speak to anyone in our manufacturing department, I always say we pray to the God of the 200 micron filter. When they ask, do we filter this product, Russell? I say, what do I say? My catchphrase is we pray to the God of the 200 micron filter, because I know if we don't catch any blockages here and they are taken to the farm and they block a filter there, then you spend hours, if not days, unblocking filters and nozzles, and that's the worst case scenario for me, because you get very angry, phone me up, complain, and possibly never buy from us ever again. So that's our number one priority, is making sure we don't have blockages. But even if we have filtered down to 200, even 100 micron, 50 micron, you can still get blockages with our products and other people's products, especially biological products. And I'm going to go explain the reasons why this might occur. And it's an ever-evolving subject, and we find out more issues that can lead to negative interactions as we know more about biological products. So even if it's not a biological product, you can still get blockages. A very common one is calcium phosphate forming. So if you ever try and tank mix a calcium product, any product with calcium in, with a phosphate product, you can get the formation of calcium phosphate. Not always, but especially if you apply it quickly. But if you leave it there for a long time, you get precipitation of calcium phosphate, the same chemical that makes up the hardness of your bones. And once formed, that's it. You're pretty much screwed. Calcium sulfate, that's another one. Any negative interactions with calcium and sulfate, you have to be really careful with. And hard water, because that contains calcium as well. In very high water, you've got a lot of calcium there, so you can get negative interactions with phosphates. So they should be listed on the label, not to mix them with certain products. Certainly with our liquid gypsum products, we say don't mix with phosphate fertilisers. But these things can occur, and the problem there is you can never dissolve calcium phosphate once it's formed. Calcium sulfate you can a bit, but it's still not readily soluble. Other forms of blockages, non-biologicals, pesticides, especially if you change the pH of the tank water, the pesticide can fall out of solution, or it can just inactivate the pesticide completely. So that's a very common one. So moving on to biologicals, here looking particularly at products that are extracted from biological material. So that could be a biofertiliser, a biopesticide, or a biostimulant. So the first one we'll look at is fish-based organic fertilizers. These are very popular. They contain a lot of nutrients and a lot of amino acids. They're often extracted with phosphoric acid. This gives them a high P value on the NPK, but it does mean that they can sometimes negatively interact with calcium products or hard water, so just check on that. Also, when it comes to fish-based organic fertilizers, they're often suspensions, and so they're not solutions, are not solubilized, and so they can settle out if you're left a long time. So if you've added your fish fertilizer to the tank and then left it overnight, then that can settle out, and it could block filters if those very small suspended particles congregate together. And also, if you store biological products in a diluted form, the preservatives is no longer going to work, because the preservatives that we use on organic products, they they're only designed to work at the dilution rate, the concentrated form. So once you dilute them, the preservative doesn't work, so that the microbes can feed on them. But if microbes can feed on them once diluted on the plants or in the soil, they can also feed on them when they're in the tank, or in an IBC. So never store diluted biofertilizers, especially fish ones, because they can, if you're in a sealed IBC or tank, it can go bang because of the biological growth. That biological growth can form strands and like hyphae that will again block filters. Even if the fertilizer is not going to block the filter, the biological growth that follows could indeed block the filter. So be very careful. Never store a diluted organic fertilizer. Another group of very popular biological fertilizers are molasses-based fertilizers. So from the sugar manufacturing, so either sugar beet or sugar cane. And here there are commonly issues when you look at the water itself. So if you add very cold water to the tank and then add molasses, it can sink straight to the bottom in a solid lump. And that solid lump can get sucked into a mixing pump and cause a catastrophic failure of the pump. So always add molasses very slowly to the tank and agitate continuously. Or you can pre-dilute the molasses in some warm water before adding it to the tank. So this is not a negative interaction with anything else. It's just the fact that if you suddenly add it to cold water, you get this big lump falling to the bottom that will just block a filter pump, and then that pump will have to be replaced. And there are examples of that happening. Okay. So now let's move on to biostimulants, and the most popular type of biostimulants are the seaweed extracts. And when it comes to tank mix compatibility on seaweed extracts, the first thing you need to do is confirm the pH. Now, you can look on the safety data sheet and the specification sheet, and the manufacturer will declare a pH. However, when it comes to seaweed extracts, you'll often find a disparity between what's declared and what the actual pH is. So go onto Amazon, get yourself some pH indicator paper and test your seaweed extract. I've seen samples that have declared a pH of 9 and have actually been 12. And so pHs of 12 are officially classed as hazardous to health, and so should have a CLP hazard classification on the label. So they are breaking the law there. And also, being so alkaline, it means that they're going to negatively interact with a lot of other things you're going to try and tank mix them with. So think about it, pH of 9 to 12, that's 1,000 times more alkaline because it's a logarithmic scale. Now, Utrema, we do produce an alkaline product, but it's a silicon-based seaweed product, so it's not got as an extreme a pH as the alkaline ones. And we produce a neutral to acidic one that is a cold-pressed one. And the reason we do that is because we take the analogy of orange juice. If I wanted to create the most concentrated orange juice, I could stick it in potassium hydroxide, which is basically oven cleaner, heat it up, and I'd extract all the pulp and the peel, and I'd get a really thick juice. Or I could just squeeze it like an orange and make orange juice, fresh orange juice, which would have neutral to acidic pH. And it's the same with seaweed extracts. A lot of seaweed extracts are sold on their soluble solids concentrate and also their potassium levels. So the manufacturers heat up seaweeds, fronds, leaves with potassium hydroxide in a big heater, pressurize it, and you get a thick, gloopy mixture out that is sold. However, we take the opinion that is bad for all the bioactives, just as it would be for orange juice, and so we sell a less thick, cold-pressed product. It still has alginic acid and the other carbohydrates in there, and also the smaller chains, things like mannitol, which is good for boron mobility around the plants, but it's just not as harsh a treatment. Now, that will be tank mix compatible with a lot more of the neutral products, certainly more tank mix compatible with the alkaline products. However, there will still be some negative interactions, and one of the common ones that I've seen is chitosan with seaweed extracts. So chitosan is a biofungicide. At Utrema, I say we make the best chitosan there is, but feel free to try other people's and then come back to ours. So chitosan is acidic, it's cationic, and it's a polymer, a natural polymer. And seaweed extract is the alginic acid is a polymer. It can be alkaline, doesn't have to be, but it's cationic. It's anionic. So you've got one that's positively charged in the chitosan. You've got one polymer that's negatively charged. You pull them together, and if you're not careful, you can create something that has the appearance of vomit in your mixing tank. So we need to be really careful when mixing chitosan and seaweed extracts, and possibly go with 2 passes on those 2 different products. You're probably not going to put them on at the same time anyway, because seaweed extract is more for establishment and chitosan is more as a biofungicide, preventing things like rusts and mildews from appearing. So seaweed extracts, pH first, but then also consider there could be other negative interactions. Another very popular biostimulant are humic and fulvic acids. So humic acid solutions are very often moderately alkaline, so about pH 9. And for this reason, you might want to avoid acidic products that bring the pH down and can take them out of solutions. We've had an issue recently where a farmer had heard that you can increase the efficacy of glyphosate by adding citric acid to your tank, which a lot of people are saying is the case. And then there are also reports of adding humic acid or fulvic acid to your tank increases the efficacy of glyphosate. And they're 2 separate reports and things. And so you put 2 and 2 together and say, adding glyphosate plus humic plus citric acid would be the best tank mix. But obviously that farmer and myself hadn't really made the connection there, and it formed a big gloopy goo that had to be solubilized out of the tank by adding some more alkaline products to get the humic acid to dissolve. So fulvic acids are normally more tank mix compatible if you can get a purer form. But if you're not adding citric acid or an acidic product to your mix, it's not going to be so much of an issue. We interrupt this broadcast to launch a new product from Utrema. Yes, we're launching a new product at Utrema. It's a seaweed extract. And I've been working in seaweed extracts for over 10 years. Well, not literally in them, but I've been a manufacturer of them. At one point, I was the UK's largest manufacturer of seaweed extracts, specifically acidic and cold-pressed seaweed extracts. I've published countless articles about them and been to international conferences. So I pretty much know my stuff when it comes to seaweed extracts. And when it comes to cold-pressed seaweed extracts, there's a couple of problems. One is the shelf life, and the other is the stability. So we wanted to improve the shelf life beyond 6 months. We wanted to get to 12 months or more, and wanted to improve the stability, because often they settle out into all the carbohydrates go to the bottom and the water stays on top. That's no good. And also they can solidify if not processed correctly. So we've produced a new product that's cold processed, flash pasteurized. And the other improvement is that it's a full UK supply chain. So a lot of extracts, the meal is dried in Ireland or Norway, they're shipped over to the UK, or the extract is produced in Ireland or Norway, Canada or China. Here, we've got Scottish seaweed that's made into a juice fresh, and then we stabilize it and pasteurize it. And so it's a stable product with a good shelf life. Now, everyone says their seaweed extract is great, and there are some great products on the market, and there are some duffers on the market. So if you don't want to use our product and you're using one already, you're happy with it, I'm happy to cast my eye over it and tell you whether it's one of the good ones or one I consider to be one of the duffers. If you did want to use our seaweed extract, ignore the prices on the website. I'm happy to do an introductory offer for any farmer who wants to use the product. It's £2 a litre. That doesn't matter if you're using a 20-litre polycan, a 200-litre, an IBC. If it's your first time using the product, £2 a litre. And obviously you'll find that is ridiculously cheap compared to all of our competitors. You're not supposed to say cheap when it comes to selling, but we make a good profit on that level, but we don't take the piss when it comes to that price. So we're happy with our prices. You'll find that we're advertising a lot in trade press now, and we're going to be publishing our prices, and that's going to shock. It's going to make a lot of the competitors livid, because you'll find that our products for things like humic acid, seaweed, chitosan, silicon, especially potassium silicate, they're going to be significantly cheaper, a fraction of the competition. So seaweed extracts, great for establishment, getting that crop growing, whether it's a spring drilled or an autumn drilled crop. The alginic acid level in there is really good. Things like the mannitol level are good. So mannitol, it helps boron move around the plant. A lot of people will tell you boron can't move around the plant. Well, it can when it's linked to a sugar alcohol, such as mannitol. So the plants like roses do this naturally, producing mannitol. Others like grasses, the arable crops don't. It's also got laminarin in there. Now, a lot of you will know that laminarin is great as an enlister of plant defences, and it's been proven to be really effective against septoria. We don't claim that on our label, obviously, because ours is not a specific laminarin product. It's just a product that contains laminarin, alginic acid, mannitol, fucans, these sulfonated polysaccharides that are found in seaweed extracts, and vitamin B12, which is a cobalt, a natural cobalt chelate. Normally, if you know me, I hate people putting cobalt onto their crop, but if it's natural vitamin B12, then I haven't got an issue with it. So check out the Eutrema cold pressed seaweed extract on the website. Thank you very much. Now back to the podcast. Next up, let's talk about chitosan. So chitosan can be used as a biostimulant, and it can also be used as a biofungicide under the EU basic substance regulations. We also use chitosan or sell it to customers for use in wastewater treatment. And that's because it combines contaminants and takes them out of solution. So things like bacteria, metal ions, even humic acid. So you can imagine those situations where they're contaminants in wastewater and the chitosan binds them and it drops out of solution. It's used in brewing for the same reason, to take yeasts that are suspended, what we call planktonic yeasts, and pulls them to the bottom of the tank or the top of the tank, depending on the type of beer. And so if we're using chitosan as a biostimulant or a biofungicide, it's also going to do the same with microbial biostimulants. You need to be careful there in the tank mix compatibilities. Because it's acidic, you don't want to be mixing it with silicon, particularly, because that will, you've got one that's an acidic polymer and one that's an alkaline polymer, and they're going to come together and form a big solid mess if you're not careful. However, they can be tank mixed if you add citric acid to the tank first. So a number of our farmers, I'd said to them, don't mix chitosan and potassium silicate or sea silica. And they did it anyway, and they did it by proving me wrong, and they added citric acid, and they worked out this process of adding citric acid to the tank first to get them so they didn't have to do 2 or 3 passes. And that's in our, and that's all their method is published in our fungicide reduction action plan that you can get off the web, or I can send you a paper copy if you want. So chitosan, it wants to pull things out of solution, things like iron. It loves to take out a solution. And so just be careful when it comes to tank mixing it. Another big group of biostimulants are the plant extracts. So there are a number of different extracts on the market that are made from plants. In America, there's a giant knotweed extract that's, I think it's Marone Bioinnovations market that's very popular. I think that might be a biofungicide actually. And some of these plant extracts are single chemicals that are extracted from plants. Others are more like a juice of a particular plant. They'll all have different pHs depending on the method of extraction and purification. So always best to do a bucket test to confirm tank mix compatibility before you apply them. Some of the examples I'm familiar with is yucca extract. So we sell this as like a natural soap. It contains a chemical called saponins. And these are natural soaps. It works best with a pH above neutral. So if mixed with acidic products, it might diminish its efficacy. It might still work, but the efficacy might be reduced. It won't fall out of solution, but that's a potential issue. Amino acid biostimulants are often from plants, so commonly from legumes, because obviously legumes are high in protein, and you can break those proteins down into amino acids and suspend them into a solution. Amino acid biostimulants are great. They sort of short circuit photosynthesis in spring, so they're really good for establishment. You can get amino acids from fungal cultures. That tends to be where at Eutrema we source amino acids if a customer wants them. The digestion of animal protein, so like pig's blood, that's a big one in the UK. There's a company selling amino acids from pig's blood. I think in Italy they make them from bird feathers. And fish waste, obviously, the protein from fish waste can be turned into amino acid suspensions. There have been reports of amino acid biostimulants having tank mix compatibility issues with ALS inhibitor herbicides if applied at the same time. And that's potentially because ALS inhibitors work by disrupting the synthesis of amino acids in the weed itself. And so if you are applying ample amino acids alongside the herbicide, then they could potentially negate the effects of the herbicide. That's theoretical. A lot of people say this. However, at the same time, the people who sell amino acids and pay their bills by selling amino acids say this is nonsense, and their products are compatible with ALS inhibitor herbicides. So that one's up for debate. So I'm not going to take a side either way. I've got no dog in the fight when it comes to amino acid biostimulants, because it's not on our portfolio of products, and it's probably not going to be on our portfolio of products anytime soon unless we find a way of making them 20, 30% better than they are currently. So now we can move on to the living biological products, and nematodes are a very popular biological product, especially in horticulture, and they are notorious for blocking filters and spray nozzles. And that's because nematodes are animals when it comes to it. They're very, very small animals, but when it comes, they're almost microscopic. You can see them with the naked eye, but you're probably best looking under a microscope to see them, a dissecting microscope. And being animals, there's only so small you can make an animal. And so really any biological product is only ever going to be a suspension of nematodes. If you buy them from, I think it's BASF that make the nematodes in the south of England, stick them under the microscope, you'll see there are billions and billions in the packet, and you suspend these up, but they won't go through very fine filters. You need to remove the filters, and the nozzles have to be larger. So even a garden rose hose, the rose on the end of a watering can, that needs to have very wide apertures to actually get the nematodes through, and you need to make sure you don't, have the pressures that just kill them, rupture them, and they can be very costly nematodes, and so you don't want to be breaking them, and their production is hit and miss. Often they're out of stock, so if you manage to get hold of some at the right time, you don't want to be killing them. Interestingly, because of the issues with tank mixing, nematodes are quite close to being delivered by drone in the UK. So they would lend themselves to drone applications because they're safe for humans. They're never going to attack a human or be hazardous to a human, and they're best not delivered in large volumes of water. So they should lend themselves well to drone applications, and I think they are now very close, if not, it's already happened that they've got authorization for applying drones and nematodes by drone. So that's an exciting area of ag biotech. So we get smaller than nematodes, we go down to the microbes, so bacteria and fungi and things like this. Obviously, the first thing is don't mix them with a fungicide or a bactericide. It's not going to block your filter, but it is going to kill the beneficial microbes. So that's an obvious one. Also, any biocide. Even many insecticides and herbicides might have antimicrobial activity, so always check with the manufacturer before combining microbials in the tank. Check with both the agrochemical and the biological manufacturer to make sure that they are tank mix compatible. Checking that is not a case of just a bucket test, because it's not just a case of it falling out of solution. You have to check whether it's alive or not. So if you're a big enough customer, the biological producer might take what you want to mix them with and plate them up on agar along with them and at the right dose rate, and check whether they kill it or not. It's certainly something we would do at Utrema. We've got a number of biological products. Our blackgrass pathogens are pathogens that impede the growth of blackgrass. We can check the compatibility of those with various agrochemicals, and we would do that for any of our customers that are trialing that. The other thing to consider is the chlorine in tap water. So most farmers, most of the time, are not spraying with tap water, they're spraying with tank water. So chlorine's not an issue. But if you, in times of low water use or high spraying volumes, farmers may resort to tap water. So always use a dechlorinator if you're going to apply a microbial product. Chlorine is also bad for the plants themselves. You can get a significant effect on the crop by applying chlorine. So it's not benign, the chlorine in tap water. And we sell horticultural dechlorinator, which is sodium free, which obviously you don't want to be applying a sodium based dechlorinator to your crop, because sodium is bad for crops. If we look at fungal biologicals, the most common one is mycorrhiza or free living trichoderma. Other types of fungal biologicals can include fungal biopesticides or even biostimulants. They're normally supplied as either spores or propagules. And spores, as you're familiar with, the spores that fly through the air are less than 50 microns in diameter. So unless they've clumped together, they should fit through a spray filter. Propagules are far larger, won't fit through a spray nozzle, not designed to be fit through a spray nozzle. They're designed to be sort of dug into the soil, certainly for mycorrhiza. You don't want to be applying mycorrhiza as a foliar anyway, because it's got to get to the roots and form that symbiotic connection with the roots. So personally, I would always go for propagules when using mycorrhiza, because they have more energy, more ability to go out and seek a plant root, whereas a spore is very small, therefore the energy has to be very close to the plant to begin with. So spores, I do buy in every now and again if a customer wants the seed coated in mycorrhiza and chitosan at the same time, but I'd always go for propagules if it was my crop. But that's if it's a perennial crop. Annual crops, it's debatable whether it has an effect. For fungal biopesticides, they're normally in spore form, water-based foliar sprays, and that's because you're looking normally for an effect on the leaf, or for a effect against a pest or a disease. Yeasts, you do get yeast biostimulants. These often elicit plant defense responses. They're single-celled. They're sort of like 3 to 4 microns, so almost like a spore, really. And so you just treat them as you would a spore. That'll be fine. For bacteria, they should tank mix fairly well because they're really small single cells. They can suffer compatibility issues with some agrochemicals that have biocidal action and kill the microbes. Again, you want to dechlorinate your water. Test your pressures and your nozzle settings and make sure they're best for the biological inoculants. And then if you combine fungi and bacteria and other microbes, then that's often something we refer to in the regen space as compost teas. And compost teas are sort of homemade, home brews. You might seed your brews with specific microbes that you've bought. It's very cost effective because you can go and get some... I wouldn't advise this, obviously, but if you got some patented microbes from some of the very big agrochemical companies and put them together, you could propagate them at home. That would be terrible because you'd be infringing the intellectual property rights of these large agrochemical companies. And you might add some humic acids and some seaweeds, some molasses, and you get a concoction. You might get some filamentous bacteria or fungi, and then spray them onto the crop. And they might have interactions with anything you mix them with, because they are loads of different species all growing together. And so you really need to be the master of those yourselves, because they are, on-farm concoctions. The actual composition will change from year to year, even if you do it exactly the same, because the temperature will be different, the water will be different that year. And so compost teas are a strange bunch. There's potential for things like anthrax growing in them and stuff like that, so you need to be really careful. You keep a tight control on safety of that when it comes to compost teas, and I wouldn't be applying them to leafy vegetables and things like that. I would be applying them early on to arable crops where there's no danger of contamination at the end of the harvested crop. So I think that covers all the types of biologicals that you might have tank mix compatibility issues with. If you think I've missed anything, let me know. And if you need any help with biologicals, if you want to got an issue with tank mixing or activity or sourcing them, then just email me, russell@utrema.co.uk. Next podcast is going to be about phosphorus deficiencies and ways to overcome that. And then after that, Josie will be back and we'll have some banter, and we'll have some more in-depth researched topics. So till next time, thank you very much for listening.